Good day, viewers. Welcome back to our mathematics class, Aliphatic teaches. Today, we are going to be talking about trigonometry, miscellaneous examples, some other examples. Before we dive into this topic properly, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. And do not forget to share to other learners for them to benefit. Now let's proceed on this. Example 1. If sine P is equal to 3 over 5 and P is an acute angle, what is the value of tan P? Now, looking at this, we are given sine P to be equals to 3 over 5. If you could recall from our previous lessons, when we talked about SOHCAHTOA, when we talk about sine, that is opposite over hypotenuse. Now, let's try to draw an angle in which our sine P will equals to 3 over 5. So let us look at it this way. So when we have a vertical and horizontal, we have angle 90. The two angles here, they are an acute angle less than 90 degrees. So let's say we have our P here. Let me call this one my A and B. Now, sine P equals to opposites. So sine P is equals to 3 over 5. Sine P is equals to 3 over 5, where this means opposites, and this is an hypotenuse. Since we're talking about sine. So when we have our angle here, the side facing your angle is the opposite. So this is the opposite, 3. While the side facing your box, 90, is the hypotenuse. Now, we can get our side PB. Let's call it small letter A. Since we have the three angles, the two sides here, we can get this A from Pythagoras rule, which states the square of the hypotenuse side, 5 square, is equals to the squares of the sum of the opposite sides, that is, 5 square is equals to 3 square plus A square. 5 square is 5 times 5, that is 25, is equals to 9 plus A square. Connect like terms, 25 minus 9 is equals to A square. So when you subtract this one, we have 16. 16 is equals to A square. Then square root both sides to get your A. Square cancel square roots. My A is equals to 4. So this value here is 4. So if we can get that value there, then we can get our tan P. Tan from this SOHCAHTOA means opposite over adjacent. So we have tan P will equals to opposites over adjacent. So which means tan P is equals to our opposites here. So when we label this one very well, this is the opposites, which is facing your angle P. This is your hypotenuse, facing your box 90. This is the adjacent. Now my opposite here is 3. My adjacent here is 4. So we have to find tan P. So tan P is equals to 3 over 4. Example 2. Given that tan x is equals to 5 over 12, what is the value of sine x plus cos x? To calculate this from what we did in the first example, having a right angle triangle, this is our x, and from your SOHCAHTOA, if you can recall again, the one that have, that is TOA, tan, is opposite over adjacent. So this is my angle. The side facing the angle is the opposite already. And the side facing your box 90 is the hypotenuse, while the remaining one is the adjacent. Fine. Now we now have tan x to be equal to 5 over 12. Tan is opposite, so this is opposite, while this one is adjacent. So my opposite here is 5, adjacent here is 12. So I can get my hypotenuse. Let me call this one P and K. So this is a small letter K. So the square of the hypotenuse sides, we have k squared is equal to the sum of the squares of the two opposite sides, k squared plus is equal to 5 squared plus 12 squared. So k squared is equal to 5 times 5 is 25 plus 144. So k squared is equal to, when you sum it up, we have 169. So square root both sides. Square cancel square roots. My k is equal to 13. 13. Now we've gotten our k to be 13, so this one is 13. Now, I now want to find the value of sine x plus cos x. Sine x, don't forget, sine x will now equals to sine is opposite over hypotenuse plus our cos x from here, cos equals to adjacent over hypotenuse. Now, from this our rectangle triangle, our opposite here is 5 divided by our hypotenuse is 13 plus adjacent is 12 divided by hypotenuse is 13. So let's find the LCM of this, which is 13. 13 goes in 13, we have 1. 1 times 5, we have 5 plus. 13 goes in 13, we have 1. 1 times 12, we have 12. So we have 5 plus 12, that is 17 over 13. So that is the value of sine x plus cos x. Example 3. If tan theta is equal to 8 over 15, find the value of sine theta plus cos theta divided by cos theta, open bracket, 1 minus cos theta, close bracket. So, from what we did in the first and second example, let us have our right angle triangle this way. Then our angle theta, let's say this is our angle theta. And from your SOHCAHTOA, our tan is opposite over hypotenuse. So where your angle theta is facing, this side is the opposite. Then we now have adjacent here. So where the boss 90 is facing is your hypotenuse, while this one is your adjacent. Now going back to these points, we have tan theta is equals to 8 over 15. So from this tan, this is our opposites. So we're going to have 8 here. Then we have our adjacent to be equals to 15. Now we have to calculate the value of the hypotenuse side now. So our Pythagoras theorem, the square of the hypotenuse size. Let me call this one small letter a. The square of the hypotenuse size, that is a square, is equals to 8 square plus 15 square. So the square of the hypotenuse size equals to the sum of the squares of the two opposite sides. So a square equals to 8 square give us 64 plus 15 square, we have 225. So a square equals to, when you sum up this one, we have 289. So square root both sides. So 289. Square goes in square roots. We have our a to be equal to. So this is 17. Fine. Now we can now calculate the values of sine theta plus cos theta. Sine theta plus cos theta divided by 1 divided by cos theta, open bracket, 1 minus cos theta. So let's place our values now. Our sine theta is opposite over hypotenuse. So, and this opposite over hypotenuse, our opposite is 8 divided by hypotenuse is the value of a that we got, 17, plus cos theta. Cos, that is adjacent over hypotenuse. Our adjacent is 15 over hypotenuse, which is 17. Let me put this in brackets and indicate this division with this sign. Now, cos theta, adjacent over hypotenuse, that is 15 over 17. Open your brackets, 1 minus another cos theta again, 15 over 17. From here, let me find the LCM here. The LCM of this one is 17. 17 goes in 17, I have 1. 1 multiplied by 8, I have 8 plus. The other one, 17 goes in 17, I have 1. 1 times 15, we have 15, divided by 15 over 17. Let me see over 1 here. Then my SCM here is 17. 1 goes in 17, we're going to have 17 multiplied by 1. That is 17 minus 17 goes in 17, I have 1. 1 times 15, I have 15. Then I proceed. 8 plus 15, that is 23. 23 divided by 17, then divided by 15 over 17. Open your brackets. 17 minus 15, I have 2 over 17. So we have 23 divided by 17 divided by 15 multiplied by 2. I have 30 over 17 and 17, I have 289. Now from here, 23 over 17. This division here changes to multiplication. Thereby 289 goes up, 289 over 30. So 17 goes here 1, 17 goes here 17. So I will have 23 multiplied by 17 divided by 30. So 23 times 17. 391 divided by 30. So that is the values of this sine theta plus cos theta divided by cos theta in bracket 1 minus cos theta. So this is some examples and applications of trigonometric ratio. If you find this class interesting, kindly subscribe to my channel and click the notification bell for my subsequent contents.